Welcome to this deep dive where we explore fascinating insights from shared sources.
Glad to be here.
Today we're unpacking some observations from Eng's gardening notes. It's all about a peanut germination experiment.
Right, and Ang actually achieved, well, great initial success. The notes mention a high germination rate.
They did, using pre-soaking in that towel method,
Hmm.
where you spread them between damp paper towels.
Exactly. So the seeds woke up nicely. Germination itself wasn't the issue here.
No, definitely not. They sprouted, everything seemed right on track. But then, well, Eng's photos tell a different story once they were planted.
Ah, yes, the growth stage. What did the photos show?
Well, you see this real mix of sizes and heights. It's
Yeah.
just random variation. Definitely not that nice, even stand of peanuts you might picture.
Okay. So successful germination, but then uneven growth later on.
Precisely. And that's the core question Eng is sort of grappling with in these notes. Why? Why this variation after things started so well?
It's like the starting gun fired cleanly, but the runners just immediately spread out all over the track.
That's a good way to put it.
Yeah.
So our mission today is really to follow Eng's thinking. See how they tried to figure out what caused this unevenness.
And what could maybe be done differently next time, yeah.
Okay, so let's get into Eng's prime suspect for this variability.
Well, Aang reflects that they didn't actually sort the sprouted seeds, specifically not by root length before putting them in the soil.
Ah, okay. So just took all the sprouted seeds, regardless of how long that first little root was,
Yeah.
and planted them.
Seems so. And the thinking here, which is fascinating, is that even a small difference in that initial root length
Could give some seedlings a head start.
exactly could create this kind of snowball effect. It makes intuitive sense, doesn't it?
Yeah, it really does. I mean, the ones with slightly longer roots probably grabbed onto water and nutrients quicker, right?
Yeah.
And established themselves more efficiently.
That's the likely mechanism. Root development is just so foundational. A bigger, or rather a longer initial root system means better access to resources right from the beginning.
So that early advantage just compounds over time,
It could, yeah. It reminds you of that principle you see in, well, lots of complex systems, actually. Small initial variations getting amplified.
leading to really different outcomes down the line.
Precisely. It tells us that those starting conditions, they can matter more than we sometimes appreciate.
So Eng's main hypothesis is lack of sorting by root length before planting is probably the key reason for the uneven growth. Seems logical.
It is logical, and importantly, it's something you can test.
Right. So for the next experiment, Eng could introduce that sorting step. Sort by root length.
And that would give some solid data on whether this hypothesis actually holds water.
Okay, but Eng also mentions thinking about another approach. Sorting the seedlings after they've mostly come up. Sorting by size, then.
Yes, that's considered too. It kind of raises a different question, doesn't it? Is that initial root length the only big factor, or maybe the dominant one?
Or can you still influence uniformity later on?
Maybe? Sorting them later, say, grouping the small ones together and the bigger ones together, might make it easier to manage them as groups. Or just observe them.
Huh. So even if some got a slow start because of shorter initial roots, maybe grouping them by their current size later could still be useful. For the experiment, I mean.
That seems to be the angle. It could potentially help figure out how much is down to the initial root length versus maybe other things affecting growth later. It adds another layer to the investigation.
And Eng is quite clear. This is all just part of the learning process. It's not about failure. It's about gathering insights for the next try.
Absolutely. That's such a great mindset. That iterative cycle, try, observe, reflect, adjust. That's really the heart of discovery, whether you're in a lab or, your backyard garden.
Yeah, for sure. So just to quickly recap Eng's main thought, the uneven peanut growth likely stemmed from not sorting the sprouted seeds by root length beforehand.
That's the primary hypothesis. And they're also mulling over sorting the seedlings by size after they've emerged as something to consider for future attempts.
Right. And the big takeaway really is Eng's whole approach, seeing this outcome not as a problem necessarily, but as useful information.
Exactly. Learning from every outcome, that's the key.
Okay, so here's a little something to leave you with. Think about that idea, how seemingly tiny initial differences, like a few millimeters of root length.
Can lead to pretty big variations down the road, significant differences in growth.
Yeah, it really makes you wonder, doesn't it? What other areas, maybe completely outside of gardening, could benefit from paying more attention to those initial conditions? Or maybe implementing some kind of early sorting.
Food for thought.
Definitely something to consider. Until our next deep dive.